Hello and welcome, everyone. I'm Katrina, a librarian here at Snow Isle Libraries. Thank you for joining us for this evening's program, Why Do Wildfires Seem to Be Getting Worse, with meteorologist Ted Buehner. Before we get started, I have a few pieces of housekeeping info to share. Your cameras and microphones are turned off and will remain so throughout the program. Please put your questions and comments into the chat window. We will also have an opportunity for Q&A at the end of the program, and overall, we'll get to as many of your questions as we can. This event is being recorded and will be available on the Snow Isle Library's YouTube page in a few days. Ted Buehner worked for the National Weather Service from 1977 to 2018 and spent the last 23 of those years as the National Weather Service Seattle Warning Coordination meteorologist. Ted continues contributing locally by sharing his knowledge and experience with the emergency preparedness community. Ted also works as a Cairo FM staff meteorologist and does weather stories for mynorthwest.com, as well as many other things. Ted has a Bachelor's of Science degree in Atmospheric Sciences from Oregon State University. Welcome, Ted.
All right, thank you. And I'm putting up a few other items I tend to keep pretty doggone busy. For instance, earlier today, I shot another video podcast. This was with the King County Emergency Manager, basically to answer the question, what is emergency management and what do they do? And coincidentally, earlier today, the podcast that was filmed last Friday regarding wildfires was posted this afternoon. And this is on the Cairo FM's YouTube channel. And they're going to put the link to that YouTube in there. It's a nice discussion with the Washington Department of Natural Resources meteorologist who was recently deployed to a wildfire. So a lot of other information that I do. And you know, when I retired, it was a question of, do I just hang it up and walk away and be selfish, or should I be generous and share my knowledge and experience with the community as a whole? So I do a lot of different things, including amateur radio and many other things as well. First of all, in the chat box, we're going to have a fun little quiz here. This is the same thing I do at the Seattle Mariners Weather Education Day. So the answers here for the question, name the 3 ingredients for a wildfire recipe. And all you have to do is put in the chat box the letters A, B, C, D, E, or F. And I can tell you there are 3 of them. So take a moment to type in your answers in the chat box, and we'll see what the results are. Now, I'm not looking at the chat box, so I'm going to rely on Robin or Katrina to provide the answers that people are offering. So far, how many have put answers in there?
Flooding in. We're
They're typing them
getting
in?
B and F consistently. A lot of
Uh-huh.
people BDF or BCF or BEF.
Okay. Do you think we've got enough of them at this point?
Yes.
Or are they still typing them in?
It's slowed down.
Okay. And there is the answer. So for those who said B, D, and F, yes, dry conditions like we have right now, heat like we're going to probably see this weekend, and an ignition source of some kind. We'll talk about the details on that here in just a moment. One more question, one more interactive element for you to do here. Now we're going to talk about wildfire weather. What are the 3 elements? And you see the choices there again from the letters A through E. So we'll give you some time to type in the answers. Again, there are 3 elements in wildfire weather. Hope you're enjoying this fun little quiz. This is the same thing I do for the Seattle Mariners Weather Education Day. We had about 2,000 in attendance prior to a day ball game down at T-Mobile Park back in May. All right, so how are they doing on their answers?
Getting a lot of A and C, but the 3rd letter is varying quite a bit.
Okay. Very good. Let me know when it slows down.
It is slowed down. I would say go ahead and give us the answer.
Okay, here we go. Let's see how well you did. So it is temperature, obviously heat, wind, Remember the LA fires in January? A lot of wind involved with that. We also had a wind event here on Labor Day weekend of 2020. We had some wildfires set up down in southeast King County and Pierce County. Anything like that, a pretty dangerous situation. You might remember in Oregon, Columbia Gorge, outside of Salem, outside of Eugene, Springfield, down in the Medford and the Bear Creek Valley, down towards Talent and Phoenix, had some deadly fires there that same weekend. And then the last element is moisture. Maybe I should say lack thereof. So very dry conditions, warm temperatures, and wind. Those are the three key wildfire weather elements. Now, I mentioned the wildfire recipe. We were talking ignition sources. Here it is. 4 out of 5 wildfires are started by humans. We just had some interesting wildfires set up along Interstate 90, near Cle Elum, just within the last few days. These were all human caused. The wildfire in the Bear Gulch area over in Mason County, that's still burning today. It started in late June. It's only 5% contained. It's over 8,000 acres at this point. That was started by a human. So usually when you see wildfires involving lightning, they tend to be in more remote locations where you may have smoke jumpers go in and tackle the fire, but definitely away from where you and I tend to wander on highways or trails, campgrounds, things along those lines. All right. Before I get into the why all this is happening, let's kind of go through some basics that I want to make sure that you're fully aware of, because you see this on television and websites, social media, all kinds of sources where you see these kinds of things, and I want to make sure that you're more fully aware of what they mean. So this is a fire weather watch. So the National Weather Service will issue this so that it alerts land management agencies of the potential, a significant potential development of what are called red flag criteria in the next, half a day or all the way up to 3 days from now. We'll talk about red flag conditions here in just a moment. And they can be issued for a particularly targeted geographic area. More often than not, it is in mountainous areas, but it can be extended down to where we live as well. Now, a red flag warning. Here are the issues. Combination of weather and fuel conditions for any 3 hours or more within a 12-hour period. So a tonight or a today or a tomorrow type of period. So those elements, remember we were talking winds just a bit ago, like the LA fires, strong winds of at least 25 miles per hour or more, including wind shifts. Those are the most dangerous ones for the folks that are out there fighting the fires. Low relative humidity, pretty dry air mass, 15% relative humidity or less. Very poor relative humidity recovery overnight. So in other words, typically at night the temperature cools down, your relative humidity will come up, but sometimes, especially if you have dry wind conditions associated with it, it won't recover very well. And then, of course, dry thunderstorms. The definition of a dry thunderstorm is a thunderstorm with lightning, but very little, if any, precipitation associated with that. And it's particularly significant if you have a lightning event after it has been warm and dry for an extended period of time. So that is a fire weather watch and a red flag warning. Now, Weather Service has what are called incident meteorologists. In fact, my guest on the podcast with Cairo FM also is an incident meteorologist. He was deployed to a fire. This one happened to be down in the Columbia Gorge area, but they can be deployed to any of our larger fires, and their role is to provide support to the firefighting teams with their local expertise. They get a lot of weather information to those teams. The briefings at 6 a.m. and 6 p.m. daily before the firefighters go out for their respective shifts. They have a lot of training already in incident command system. They know how to handle hazmat responses, for instance, a lot of media training. And they have a lot of tools, if you wish, resources ability to drive into more remote locations and have satellite technology to be able to draw down weather information for wherever they may be. And here you see an incident meteorologist actually using local weather instruments to get an idea of what the temperature, relative humidity, and wind speed are in that particular location with that fire, not too far away. So where do you get fire weather products? Well, for us here in Western Washington, most of the region is covered by the Weather Service out of Seattle. There's their website. If you don't already have it bookmarked, please jot it down. You'll be able to use that. It's a great resource for not just for fire weather products, but a whole suite of information: Doppler weather radar, satellite imagery, current forecasts, watches, warnings, advisories, flood information, go on down the gamut. The other offices that serve Washington State are Spokane, Pendleton, Oregon, and Portland, Oregon. Or if you're interested in things that's going on across the nation, such as Hurricane Erin off the East Coast right now, really kicking up the surf and rip currents along much of the eastern seaboard, you can go to weather.gov and zero in on the area that you're interested in. Other resources include the Northwest Interagency Coordination Center. They're located down in Portland at the Portland Airport. You see their website there. I mentioned the Washington State Department of Natural Resources earlier. They have a lot of information about wildfires across the state at this point, daily updates on that. And then, of course, the National Interagency Fire Center, which is located in Boise, Idaho. They have more of a national perspective with regards to all the wildfire activity and resources being deployed across the nation. All right. Now, I'm the chair of the State Emergency Communications Committee, so I've got to talk about the emergency alert system and wireless emergency alerts. So one of the key elements that is not necessarily weather related, although it technically could be, but is the fire warning event code. This is what activates the emergency alert system. You can get it on your weather radio, like this one right here that I'm displaying. Handy lifesaver for the cost of a pair of shoes. That's one way to receive these. Also, we'll talk about your smartphone here in just a moment. It also goes out to all the broadcasters, so radio, television, cable. Fire warning. We'll talk about the definition of that here in just a moment, but it is issued by your local jurisdiction. So maybe Snohomish County, Skagit County, Island County, King County, anybody like that. If you're from Eastern Washington, we get a lot of wildfires in Okanogan County and Chelan County, Douglas County, just to name a few. So you can receive it on your weather radio and all of the broadcasters, television, radio, and cable. And there's an example, another one, of a weather radio. This is the tabletop model. There's also handheld models that you can take with you when you're out camping or fishing, whatever your outdoor activity may be. The other side of this coin is wireless emergency alerts, again, issued by your local jurisdiction. So when they activate the emergency alert system, they can activate wireless emergency alerts and NOAA radio all at the same time. And wireless emergency alerts, they're the ones you receive on your smartphone. Probably have received Amber Alerts. That's one good example of that. And if you would like to learn more about the Washington State's Public Alert and Warning System, or WAPAS, there is the website that is hosted by Washington State Emergency Management. Again, I'm the chair of that, talking with broadcasters and engineers, emergency managers, etc., from across the state. We're all in a team effort to try to enhance the system so it serves the public in the best manner possible in case we ever have a significant warning event. All right, I talked about fire warning. What does it mean? So the bottom line is a warning of a rapidly spreading wildfire or structural fire that threatens a populated area. I like this photo here. You see the city lit up below, and there's the fire in the hills above. This is exactly what was issued during the LA fires in January of this year. So you see, more often than not, you're going to get instructions from your local authorities what to do. Usually it is get out of Dodge. Find places where they want you to go to shelter in place. Maybe it's in shelters, maybe it's somewhere else in the county or neighboring counties, those kinds of things. This is for a rapidly spreading wildfire, an immediate life-threatening type of scenario. Wildfire smoke. My goodness, we've had this now 7 out of the last 9 summers. And this year, I've talked to many people. They say that Bear Gulch fire over in Mason County has created a lot of wildfire smoke. Maybe not necessarily poor air quality here in Snohomish County, but definitely from King County, Kitsap County, and further south into the South Sound region. But it all started in 2017. I don't know about you, but I don't remember this being an issue before that. 2017 is when we had the wildfire smoke come down out of British Columbia, and it just blanketed the region with poor air quality. So the sources can be local, such as what's going on in Mason County today, or it can be distant. It can be coming from California, Oregon, Eastern Washington, or British Columbia. Those are the most common sources of wildfire smoke here in roughly the past decade. Now, with regards to wildfires, what can you do? So these may be seeming pretty obvious, but 80% of those fires are started by humans. People still fire off fireworks, even though it has been warm and dry for an extended period of time. That's one cause. Yard debris burns, stuff will fly away into the wind and drift downstream and start a fire maybe a half mile away or something like that. That is another issue. Campfires. If you're out camping, make sure that campfire is cold before you leave. The fire that was along the Stevens Pass Highway in 2022, that was started by a campfire that it was not cold. So wind came up, kicked it up, got it alive, and off she went. And then motor vehicles. We've already had our share of roadside fires, people taking lighted cigarettes or the like and tossing it out the window as if it's the month of November. But in hot, dry conditions, especially with some wind to kick it up, it can create those roadside fires like we had in Smoky Point here. It was about 3 or 4 weeks ago now. Great image there of an urban interface wildfire. Some people think it'll never burn here, but yes, it can. And we saw that with the LA fires, for instance, just whipping through neighborhoods one after another. Plus, those hot embers got thrown up into the wind and started new fires 3 miles downwind from where it came from. So what can you do at home? And this is one thing I really emphasize a lot. Go to firewise.org and you create a defensible space around your home or your business because this is where you live, this is where you work. And what is defensible space? Well, you can go to the website and get details. But I'll give you some examples. Number one, if you got trees in your yard or around it, limit all the way up to at least above your head. That way a fire on the ground can't get up into the tree and take off. It's called a ladder fire. Another one, maybe you have firewood curing next to the house. You're ready for winter already. That's great. But move it away from the house because that is just asking for an ember to get in there and start a fire there and then spread to the house pretty quickly. Another simple one, clean the roof, clean the gutters, get all that debris out of there. So again, if something drifts out of the sky into your area or a firework lands on your roof, that won't catch fire there as well. More examples in firewise.org. I hope that is a helpful resource. Now let's get into the why. Why are things getting worse? Well, first let's talk about something you probably learned back in middle school called the greenhouse effect. I think we've all been in a greenhouse. You get in there and it's warm and it's moist, even though outside it might be sunny but 40 degrees. So your incoming sunlight is what's called shortwave radiation. And the graphic kind of describes a lot of that. Coming in from the sun itself, some of it's absorbed, but most of it's absorbed by the Earth's surface, whether on land or in the oceans. Some of it's reflected by clouds or maybe snow on the ground as an example, and reflected back out to space. Now, the greenhouse side of this formula is that the heat that is absorbed by the land and the ocean, well, it starts to radiate at night. That's called long wave radiation. Some of it goes all the way out into space, but the more greenhouse gases we have, so we're talking carbon dioxide and methane, those are the two primary ones. Nitrous oxide is another one, but carbon dioxide and methane, which is more effective than carbon dioxide, by the way, with regards to being a greenhouse gas, helps to deflect and bring and keep that heat in there, just like a greenhouse. And I saw somebody on social media say, well, we don't have windows in our atmosphere. Well, technically, we do. And it's called the tropopause. So weather occurs from where we live all the way up to maybe 50, 60, 70,000 feet. And at that point, it goes into the stratosphere. The stratosphere is warmer than it is below it. So it literally acts as a lid, call it a window. And that is where that heat is trapped in the lowest layers of the atmosphere around the Earth's surface. So we were talking about greenhouse gases. Back at the start of the industrial age, it was about 280 parts per million. And I could probably ask people to raise their hand how many have been to the big island of Hawaii. Well, on Mauna Loa, there's been a weather station there since the 1950s, and among all the weather elements that they measure, one of them is the amount of carbon dioxide. Now, the chart you see here, starting on the left-hand side at the start of the industrial age in the late 19th century, slowly increasing the amount of carbon dioxide parts per million. And somewhere around 1960, it really started to take off and go sharply higher. And so I've got on the right-hand side here the list of average amount of carbon dioxide for the month of May at Mauna Loa. This is out in the middle of the Pacific, no industry, no cars. It's a great place to sample the globe's perspective with regards to the amount of carbon dioxide. 2022 was at 421 parts per million. Next year, 2023, 424. In 2024, jumped up to 427. And I made a phone call here a couple months ago and found out that this year it was at 430 parts per million. So it continues to rise, the amount of carbon dioxide that we have in our atmosphere. Now, some say, well, it's happened before. We've had warm planet, etc. If you look at ice cores going back almost 1 million years, that's what you see depicted here, is the amount of carbon dioxide parts per million, all staying under that 300 parts per million level until we get into the start of the 20th century. And you can see that literally a hockey stick just jumped straight up to where we are today, now in excess of 420 parts per million. So if you look at the ice age going all the way back more than 800,000 years, it's just been in the last roughly a century that things have really taken off. And that's because we've been burning fossil fuels in one way or another. Of course, this has an impact on our temperatures. So here we're looking at the start of the industrial age, our global temperatures based on an 1891 to 1910 30-year average. And you can see it stayed pretty steady as we headed into the 20th century, started to come up a little bit into the 1950s, but right around the 1960s, that's when it started to climb pretty dramatically at that point. Now, keep in mind, our warming planet is not uniform. Probably the most significant warming has been in the polar regions. So you probably heard the term permafrost. A lot of infrastructure in Alaska and Siberia, etc., Norway, Sweden, built on top of frozen ground. Well, now it's thawing, so we're having a lot of infrastructure that is starting to fail around the globe. It doesn't matter which country you want to talk about. And unfortunately, in that permafrost, guess what? There's more greenhouse gases, more carbon dioxide, and more methane that is now escaping, and it's just exasperating the situation. The right-hand side, you can see from 1972 to 2021, the temperature trend across much of the lower 48, as well as the state of Alaska. Overall, we're just warming up. That's the bottom line. So why is all this happening? Why are wildfires seeming to get worse? Well, I'm going to use a quote from a fellow meteorologist, Doug Stoltz, and he quoted this. He literally sent me an email about this, and he says, not only are we experiencing the reality of the warmer atmosphere holding more moisture, I'll get into that in just a moment, but also shifts in when and where the moisture is deposited. So I mentioned more moisture being held in the atmosphere. A warmer air mass can hold more moisture. Right now, since the start of the industrial age, at least 10% more moisture is in the atmosphere. The status of the climate report from the American Meteorological Society came out last week, and they have found that water vapor, the amount of moisture in the atmosphere, is at all-time highs around the globe. This is in part why we're seeing such heavy rainfall amounts in the same amount of time period that it did 40, 50 years ago. And we're seeing more flash floods, we're seeing more flooding events, whether it's in this nation or if it's anywhere in the world at this particular point. Excuse me. And he also mentioned shifts in where this is being deposited. So if you look at Europe right now, they have had one heat wave after another because storm tracks have been well to the north. That's why you're seeing wildfires in Spain and Portugal and Greece and other places in Europe right now. It's not just North America and Canada that's on fire, but other parts of the globe as well. Doug goes on to say we are seeing a higher frequency of jet stream blocking events, increase in the magnitude of flash flooding, the rain rate, which I just mentioned, and expansion of drought conditions, which we are experiencing ourselves right now. We are so far behind on rainfall, despite the recent rain we've had so far this month. That was literally a drop in the bucket compared to everything else. And he mentioned jet stream blocking. You remember the heat dome that we had in late June of 2021? That was where the jet stream went way north and completely got stationary, got blocked, and sat over us. And that's why we had that extreme heat there towards the end of June in that year, with all-time record temperatures crushing the previous ones. Wildfires and smoke. We got lots of examples. I mentioned the Mason County fires that are going right now. We had fires up in Whatcom County last year, the Bulk Creek fire here in Snohomish County just a few years ago. And I need to update that slide. It's now 7 out of the last 9 years, because I've talked to people just in the last week or two about the wildfire smoke from the fires over in Mason County. Of course, the poor air quality. The picture you see down there, if it says 2017, that was the British Columbia wildfire smoke. That was the first time we had it drift down here and just blanketed the region. And I've got a list of worldwide examples. Just go almost anywhere in the world right now. Somebody is on fire, whether it's the winter season for us, summer season for the Southern Hemisphere, such as Australia is an example of that. France, Spain, Portugal, Greece, all burning. So again, some more on why. Let's look at the fingerprints, is the way I like to call it, of a warming planet. So Dr. Yuping Guan looked at data around the world for temperatures from the 1950s until 2011, and what he found is our summers are longer. I think we have intuitively figured that out because we're experiencing it, but it really is, because here's some of the results. He found from the 50s to 2011 that the number of days on average of summer around the globe has increased from 78 to 95 days. And that was during that time period. That's over 4 days per decade. Obviously, the length of winter, spring, fall, all the other seasons have decreased. And he found that all seasons, doesn't matter which one, all 4 seasons were also warmer. And if we look at the previous decade, the 2010s themselves, that trend has continued through that decade. And we just found that 2024 was the warmest ever recorded. Again, the State of the Climate report from the American Meteorological Society released last week showed that 2024 was warmer than 2023, which was also a record at the time. And we've had numerous records over the last decade or so, so far this century. Another example of this is annual temperatures compared to the 20th century average. So we're looking at the middle of the 20th century. Early in the 20th century, you see a lot of blue, cooler than average from the middle of the century. But by the time you got to the 21st century here, going up to 2020, you see a lot of red there, definitely warmer over time. So that's a nice comparison of 30-year averages from the start of the 20th century spilling over into the beginning of the 21st century. Our most recent 30-year averages were released in May of 2021. So the previous one was the 30 years from 1981 to 2010, and the most recent is 1991 to 2020. So the two charts you see here, temperature on your left, precipitation on your right, is the difference with just those 10 years between those two 30-year averages. You can see temperatures are warmer on average across the lower 48. We could probably include Alaska in there as well. And then precipitation wise, remember Doug Stoltz talked about how things are shifting around. You see probably the eastern 2/3 of the nation tending to be wetter than average. We've seen a lot of flooding events there in the mid-Mississippi and Ohio valleys and Tennessee and Kentucky here in recent years. Just had some major flooding in Milwaukee, Wisconsin. You can think of other examples. The Hill Country in Texas is another one. Meantime, the desert Southwest and much of the western U.S. is tending to be a little drier. For us, we're just hanging in here about average, maybe just a little drier here, a little wetter there, but overall not too much change compared to much of the rest of the nation. Now, I bring that up because I want you to look at these two U.S. drought monitor charts. They are 10 years apart, 2011 on the left, 2021 on the right. We were talking about evolving weather patterns and shifting weather patterns. That's what you see reflected here. So we're talking essentially 15 years ago, we had drought conditions across the southern tier of the U.S. That's what you see in the reds and the oranges there. 10 years later, right around the 4th of July, everything has shifted to the western third of the nation, while the rest of the nation has been pretty close to, average conditions, no real drought concerns in that regard. If you're interested in that, you can always look up that website there, but I did bring up what we look like here recently. So basically, almost all of the state of Washington is in some form of drought, whether it's abnormally dry in the yellow, moderate drought in kind of a lighter orange or tan color, severe drought, and then going all the way to extreme drought in some cases, particularly along the spine of the central and northern Cascades and onto extreme southeast Washington. So we've been extremely dry, and here's some statistics from Everett Payne Field. At this moment, despite the rain we had earlier this month, we're still more than 12 inches behind for the year, only 30% of average. And our 30-year average is 31 inches per year. You can look at the numbers there. 2020 and 2021 were wetter than average, but we've been dry in the last 4 years. And this year, we're getting close to 6 inches so far for 2025 based on the recent rain. But the bottom line is we're way behind and very dry. And remember, the recipe for wildfires is dry conditions, heat, and some form of ignition source. So what's it look like for the rest of the summer and into this fall? In the upper left-hand corner, you see the poker chips there. That's what I want you to think of. Think of the poker chips in below average, near average, and above average. Those are the piles of poker chips. For temperatures on the left-hand side, we're looking at the 3-month period of September through November. They have stacked the odds. About 40 of those poker chips are stacked in the above average temperature categories. We're talking the entire 90-day period. So you're going to have warmer periods, you're going to have cooler periods, but overall tends to be warmer than average. On the right-hand side is what's it look like for precipitation. Right now, those poker chip piles are dead even, 33 in each pile. So equal chances of above, near, or below average precipitation. So that's what the outlook looks like as we head in towards the Thanksgiving time period. So as we wrap up, I have a few takeaways for you. Number one, our wildfire seasons and our summers are getting longer. I think we've intuitively figured that out. We've seen it, but that's what the statistics are showing us. And from your perspective, Always be aware. Keep your head on a swivel with regards to what is happening with the weather, particularly when we have extended warm and dry periods. Again, that's part of that wildfire recipe to be warm, dry, and those ignition sources, 80% of them are human. Actions that you can take, well, keep those burning materials in the vehicle, tighten up those tow chains for those who tow the RV or the boats, whatever the case may be. Follow those local burn bans, avoid the outdoor burning but until they lower those burn bans. Right now, every county in Western Washington, in fact, almost every county across the state has an outdoor burn ban in place at this point. Campfires only within designated campfire areas, nothing that you can do just off on your own. You need to have it in a designated area. And of course, if you see smoke, particularly if it's associated with a wildfire, always call 911 so that fire responders can get on it before it gets too far out of control. So that is my presentation for this evening. One of my great slogans is, when you are weather aware, you are weather prepared. And I hope you've enjoyed this presentation, and we'll be ready for some commercial or questions rather when you are ready.
All right, well, thank you so much, Ted, for your presentation. We're going to move into the question and answer portion. Moderators have been pulling questions from the chat during the program and will continue to do so throughout the Q&A. So keep those questions coming and we'll get to as many of them as we can. Let me go ahead and take a look at what we have. Okay, first question, how does a weakening La Nina jet stream affect wildfire season?
Well, first of all, El Nino and La Nina are more winter season impactful. So in this time of year, our jet stream, what weakness of it has is further north overall. And that's what we are experiencing even as we speak today. So right now we've got strong high pressure over the southwestern U.S. that's going to be building up over us as we head into this weekend. And that means we're going to have more sunshine, warmer conditions, getting above average temperatures, and the jet stream will be way north, even probably north of Juneau. That's how far away it's going to be. So keep in mind your El Nino and La Nina type of phenomenon, even neutral years, are during the winter season. Very little, if any, impact on our summer seasons. And now I mentioned summers are longer, so that means we're seeing less of an impact from El Nino and La Nina, kind of stretching the seasons out from, say, May to October as opposed to April and September, if you get what I'm saying. Thank you for that question.
Okay, next question. What does the percent contained number mean? And this was asked pretty early on in the presentation, and I think it might have been when you had the slides on the greenhouse effect, but I'm not sure. So Gerald, let us know if that is incorrect.
I think he's referencing to what does it mean to have a wildfire contained? It is where those lines have been built and where the fire is not going to spread any further. In the case of the Bear Gulch fire, it is in very steep, rugged terrain, and it is a tough job. I mean, you've got, hillsides are steep angled and things like that. It's a tough game that's going on over there. I will say the recent rains have helped, if I can use the pun, dampen it, but it's still burning. And we're going to get back into really warm and dry conditions. So in a few more days, it'll be as if that rain had never occurred. Hope that answers your question.
Someone is wondering, are we at a tipping point?
Well, I wish I could have more clarity. I think I know what they're referencing. I hear a lot of discussion with regards to our warming planet. Are we at a tipping point where it's really going to swing in a sharp direction towards warmer conditions? I'll tell you, unless we can bring down or stabilize the amount of greenhouse gases that we're putting into the atmosphere, we may be getting close to a tipping point. That's a good scientific debate that's going on, but you can't argue with the numbers, and we're seeing some of the impacts from it as we speak. We got Hurricane Erin, for instance. It ballooned up to a Category 5 a few days ago, and it was because it went over extremely warm ocean temperatures. If we get any tropical cyclones getting into the Gulf of Mexico anytime in the next few months, sea surface temperatures are in the mid and upper 80s. It's essentially bath water. And it takes for hurricanes to blossom, if you literally fuel on the fire, it's a minimum of 80 degrees Fahrenheit. So if anybody's concerned about hurricanes here, no. If you ever stepped into the Pacific off the coast there, we're lucky to get to 60 degrees. It's that cold. So that's not going to be the case here. But we can get hurricane force winds with our big storms, such as our bomb cyclone that we had last November. But those are deep ocean storms as opposed to hurricanes. I hope that answered your question.
Okay, so someone would like to know, have you seen a recent decrease in weather staffing
I'm going
nationwide?
to take a guess about the Weather Service. So I still have inside contacts, and they had a lot of people that left between the end of January and April 30th. I think a lot of elected officials in Congress saw that too many of their local offices were no longer able to be 24-hour a day staffed. And now that pendulum is starting to swing back. First, it was adding another 125 people with the oncoming hurricane season. And now they're adding a few hundred more. Here's the issue. A lot of experience and knowledge walked out the door. So bringing in new people, that's fantastic news, but they got to go through a training and orientation period. It's not like you walk in and start all over again. It takes some time for them to spin up, gain that experience, get assigned to the respective office where they're going to work, and off we go. But that's going to take at least another year or two, depending on the hiring process.
Hmm. How are urban forests changing, and are there possible risks of that?
All right, I'm not a forester, so but I did sleep at a Holiday Inn Express. I guess I could use that joke. Um, Generally speaking, in talking with them, yes, our forests are evolving. I think that might be one way to put it. Particularly Eastern Washington, we've had a lot of nasty bugs that get into the wood and tend to kill the trees. Here locally, I don't know if you've noticed it, but I've got some trees near my home here, and they've got a lot of limbs that are turning brown. They're kind of self-thinning, if you want to call it that. A lot of tree debris being dropped from the trees because they're trying to save themselves. And so you are going to see some evolution in the types of trees. Doesn't happen overnight. We're talking decades for that to occur. But yes, you're going to see some evolution in what kinds of trees are supported in certain areas, depending on the amount of moisture and available sunlight to work with.
Someone would like to know, as a gardener, how can we best prepare for the heat and dry conditions?
Excellent question. I'm glad you asked that one. That's part of your defensible space effort. So there are a lot of fire resistant plants that you can have. I've seen some yards being developed more desert like things, so they may have more round rock and other shrubs that are more fire resistant instead of the usual grass, which this time of year browns out and can be accepting fire very easily. So again, firewise.org, a lot of answers are there, and there are other online resources that help provide you with information about fire resistant plantings that you can have around your home.
Wonderful. How can we realistically lower greenhouse gases and impacts over the next few years to stop the 2050 collapse?
Oh, that's a good question. And it has to be a worldwide effort. I know the state of Washington has jumped in with maybe both feet to try to do their part. Other parts of the country, as rest of the world, also need to do the same thing. Bottom line is we need to slow down or almost nearly halt the burning of greenhouse gas materials. In other words, our petroleum products. Got to go to more reliable, renewable resources. There's been a lot of talk about next generation of nuclear power, the wind systems, whether it's on land or at sea, solar panels. Our warming planet means that we're going to see more sunshine, which means that solar panels are going to be more useful. I've got some neighbors that have put up some solar panels on their homes, and that's helped to drop their power bills. So these are some of the things that can be done. And the question is, can the rest of the United States, state of Washington's doing its part at this point, but also the rest of the world be able to contribute to that effort? Otherwise, we will potentially reach that tipping point.
Do you see an increase in the relationship between microbursts and lightning strikes in the increase of wildfires?
No, I really haven't seen that. Now, some wildfires can produce their own weather, and that can be in the form of what's called a fire whirl, basically a mini fire tornado, very dangerous, by the way. Also, they can create their own thunderstorms, and that's where you can see some microbursts associated with that. But more often than not, thunderstorms that drift over a fire area, and I've seen it happen numerous times. That's where I talked about shifting winds being very dangerous. That's where a microburst, even in a mountainous or rough terrain area, can play a big role in how people who are fighting the fire, they may need to take shelter to get out of harm's way and not become a victim in that. We've seen that, unfortunately, in several wildfires down in Arizona, even in central Washington in recent years. But microbursts are pretty rare, but they can and do occur.
Impacts are there in the decrease of weather personnel?
I'm sorry, could you repeat that question again?
Yeah, someone's wondering about the impacts in the decrease of weather personnel. How are we seeing that play out in terms of what the impact is?
Well, those that are remaining, putting in long hours, adds a lot of stress to their lives, a lot of stress to their families. Um, some of them need to take time off for mental health reasons because it really adds up on you at a time. I'm going to use the example from the Texas Hill fire. A lot of discussion about the loss of weather service personnel, etc. But I can tell you, in talking with the people in the Austin/San Antonio office, normally you have 2 people on overnight. They had 5 people that night, early morning on July 4th. I recently did a presentation for King County Emergency Management on the step-by-step process that occurred with that particular event. For instance, on Thursday afternoon, the day before, they did an online virtual weather briefing for the emergency management community and elected officials about the potential of flash flooding that night. So anybody says they didn't get the word in the emergency management community either didn't attend that meeting or weren't paying attention. So a lot of people were aware of that. In fact, the state of Texas Emergency Management pre-deployed resources into the region because they took that threat seriously. So there's an example of adding people on an overnight shift during a high stress, high impact type event. A lot of efforts were made to try to help reduce the loss of lives and property. And unfortunately, we had a lot of people who did not get the message and get out of harm's way. 135 lives lost, 2 are still missing.
What was the most devastating wildfire last year, and what is the expectation for recovery after a large-scale fire?
Oh, another good question. Probably, if we're talking locally, it was probably the Whatcom County fire. If we're talking more globally, I would have to say it would be the hundreds of fires in Canada, 2023, 2024, and occurring right now. That's why I think a lot of people in the central and eastern U.S. have experienced wildfire smoke for the first, second, or third time. They're now realizing, oh, that's what the western U.S. has been experiencing. Now I get it. Okay, so they're actually experiencing this kind of thing. And of course, if you want to talk January of this year, I know it's not last year, but this year, definitely the California wildfires. We had several of those there, very devastating wildfires there that burned through neighborhoods, one after another. Just, I forget the number of homes that have been destroyed, but last I saw, the price tag on it was around $35 billion worth of damage, and they still haven't finished that final assessment yet.
How can you keep your garden moist and fireproof without contributing to droughts?
Well, I have a drip system in my yard. And I, don't use it every day. I do it about every other or maybe every third day, but to try to keep the ground moist and not throwing water up into the air to get evaporated. So that's one way to help do that. I don't have grass in my yard. I took it all out, so I'm basically all vegetation out in my front yard where I have that drip system. I'm not sure if that answered your question or not, but that is the process that I practice.
Great. Are 100-year floods now 10-year floods?
Oh, there's an example. Where is my little ball? There it is. I do this in my National Disaster Preparedness training sessions. So let's talk about what is the definition of a 100-year flood. So what I'm holding here is a 100-sided die. Yes, they are out there. And I've encouraged the emergency management community to use this as a nice public education tool. So, Robin, I know you're not on camera at the moment, but pick a number between 1 and 100.
77.
I'm sorry, was that 27?
77.
77. All right, you're going
No.
to hear this. You can't see it, obviously, because my microphone is not and camera are not in the right place. But I'm going to roll the die and see where it stops. You can probably hear it rolling there. And it came to a stop. And Robin, it finished at 42. So what I'm demonstrating is Robin had a 1 in 100 chance of getting that number of 77. If we did it again for all of you, you would have that same odds, 1 in 100 chance. That is each year. So each season on each river system, you have a 1 in 100 possibility, a 1% chance of having a 100-year flood. Now, the definition of how high is a 100-year flood varies from river to river, and all of that information is available through the USGS or the National Weather Service Rivers and Lakes page on their websites. Again, that's weather.gov/Seattle. But again, it is a 1% chance for this year. It's a 1% chance for last year. It's a 1% chance for the coming year. You get the idea. It's like literally rolling a 100-sided die. And I hope that answered your question.
You think an air purifier put in a home can help when there's wildfire smoke in the area?
I have one. And so the short answer would be yes. There are other tools and resources to help do that. When we have wildfire smoke, unfortunately, you got to close the windows, close the vents. If you're in a commercial building, the HVAC system, shut everything down so that you don't have the smoke being ingested into the home or into the business. And you remember the N95 masks that we had during the pandemic? Those are great to keep the wildfire smoke out of your lungs. By the way, a lot of this isn't talked about unless you talk to people from public health. You breathe in that smoke, those smoke particles, they're not leaving your lungs. They're there until forever. So you really want to try to avoid breathing in the wildfire smoke as much as possible because it will stay with you long after the wildfire smoke is gone. So keep that in mind as well. It's particularly harmful for those who already have respiratory issues or maybe some form of heart ailment. So keep that in mind as well, particularly for older folks.
What is a fire tornado?
That's a fire whirl. I kind of described that earlier. Usually it's a very hot, intense fire, and it gets just a little bit of rotation on it, and then it takes off on its own because the heat's rising, so it'll get that rotation going and get going on its own. They're very dangerous because you don't know where they're going to move. That's one thing. They don't have a steady path that they follow. So any firefighters that are anywhere near that, they're getting out of harm's way. Get out of the way of that. Hopefully that answers your question.
Someone would like you to discuss the natural glaciation cycle over the last 800,000 years compared to what faces us today.
Well, are you talking mountain glaciers? I can tell you if you look at the State of the Climate report from 2024, the one that just came out from the American Meteorological Society, they have a segment on our glaciers and what is happening with them on a global scale. They've been following, I think it's 58 glaciers around the globe, southern hemisphere, northern hemisphere, and tracking where their ice is and how it's moving. And for the 13th straight year, they've all retreated. And I think we just saw what happened with the Mendenhall Glacier outside of Juneau. I was just up there a couple summers ago myself and saw it firsthand. They have what is called a glacial outburst. In other words, the ice forms a little bit of a dam. You got a lot of melting going on upstream in the glacier itself, and then it reaches a breaking point where it's almost like a flash flood. It lets go, and here comes that volume of water. And they had another flood in parts of Juneau here just a week or so ago. Same thing happened last year, last summer. It did not happen when I was there, but it happened a few weeks after I had visited in August of 2023. So I hope that was addressing what you were referring to. I know you mentioned 800,000 years, but all the ice cores have looked at the data and the amount of carbon dioxide within the ice cores, all of it under 300 parts per million until we got into the 20th century when things went up.
I'm not seeing any clarification about that in the chat, but if I do, I'll communicate it.
Okay.
It seems more utility companies have contributed to wildfires and now turn off power to affected areas. How much of a problem is this?
Oh, that's a double-edged sword. So power companies do their best to make sure that their equipment is not going to spark fires. I can think of the Camp Fire that was in Northern California in October of 2018, swept through the town of Paradise, literally burned the town down. California's most fire fatalities, 85 of them, if my memory serves me right, with regards to that particular wildfire. That was started by equipment. Another one outside of not Santa Rosa, but it was north of San Francisco. The town's name slips me at the moment. Don't ask me why. It was the Tubbs Fire, also in 2018, also started by electrical power utility wires. When the wind is blowing really hard, even though they've got everything tightened down, there are certain things that can happen because of the strong winds. So you're starting to see more and more power utilities. California is a good example of that, but it's even throughout the rest of the Pacific Northwest having to make the tough choice of shutting the power down so that we don't have that kind of wildfire get started while the wind is blowing. The downside of that is you turn off power to homes, businesses. You've got some people that have an absolute need for electricity. Breathing machines, kidney dialysis, things along those lines from a medical perspective. So there's some negatives. Again, this is where the power utilities got to work with the local communities and determine where do people need backup power supplies in case the power needs to be turned off. This is even true during windstorms, our typical October, November, December, January, February type windstorms where you lose power just because of the windstorm itself. Again, another need to be able to provide backup power for those who really need that backup power in case the power system were to fail in their particular area. So I hope that answers your question.
I have not seen any new questions come in the chat in the last couple of minutes. So if anyone else has a question, go ahead and get it in there now.
You got a meteorologist in the house. Here's your chance.
Yeah, golden opportunity. And we'll just give people a minute to think of that. Okay, I think that we've reached the end of our questions. So thank you so much. A big thank you to Ted, and thank you to everyone for listening to this presentation. Oh, a couple of late breaking questions if you have time. I think we're
This
ahead of
just
time.
in. Okay.
How do we define summer to know it is longer?
Oh, that's a good question. And Dr. Yuping's, Guan's study uh, discusses that. So it based it upon the temperatures as they've warmed up, where that line has spread out earlier into the spring and later into the fall. And it's not just the Pacific Northwest or the US or North America, it is globally. So we're talking Australia, we're talking Africa, we're talking South America, anything south of the equator or north of the equator where all of this has been analyzed. He has a much more definitive term on there, but there is a threshold where that occurs. Good question, because I asked it myself.
Okay, so I know that you touched on this briefly in your presentation, but can you do a quick recap of what is coming up for us this winter?
Well, I could go back to that slide, I suppose. Oops, one more. There we go, right there. So if we look at the fall, here we're looking at tipping the odds in favor of warmer than average conditions and no real determination on a trend for precipitation. If we get deeper into the winter season, there's a little bit of debate. It's hard to do a seasonal outlook in the summer, but by the time we do the one in September, we'll have a much firmer feel. But if I was going to put money down on, use those poker chips, if I was going to put them down, I would lay odds that we're going to go into a neutral season, so not El Nino, not La Nina. I've heard some discussion about maybe going into a weak La Nina. That is still a possibility. But if we go into a neutral year, they tend to be wetter than average in our area. So when it comes to flooding, that becomes more of a distinct possibility. Our flood season gets started right around the end of October, really maxes out in November until we get a mountain snowpack, and then it slowly but surely tapers off as we go into December, January, and February, and on into March. Temperature wise, right now, it still looks like we're going to be tipping the odds towards at least, or shading the odds, that might be a better term, on warmer than average temperatures. But again, it's tough to do that in the summertime. We'll know more in just another, well, roughly 6 weeks from now.
Okay, so stay tuned for more.
Well, that's what we do. Stay tuned. We want you to
Yep,
be weather aware. Stay tuned.
always be tuned. Does global temperature increase affect earthquakes?
Talking with seismologists, because I've heard this question before, the answer is no. That was short and sweet, wasn't it?
Yeah, good answer. That's the answer we all wanted to hear, I think. Okay, well, on that note, I think we've reached the end of our questions. So thank you once again.
Well, if I can wrap up, it's
Yeah,
it's always a pleasure to share all this information with you. It's been an honor and a pleasure. Thank you very much.
our pleasure as well. Thank you so much for joining us. And thank you to everyone in the audience for joining us and for all of your questions. And be sure to check out the Snow Owl website for more online events, including our interview with Pulitzer Prize winning author Tessa Hulls on September 30th. You're getting lots of thanks in the chat as well, Ted. Lots of people saying thank you so much. Very informative. So have a good night, everyone, and we hope to see you again soon.